Section 4.6 is called corresponding parts of congruent triangles. Make sure you place that into your table of contents, and then let's set up a new sheet for some notes. In section 4.4 and 4.5, we established that triangles can be proven congruent by our four congruence shortcuts: side, 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 angle, side, angle, and angle, angle, side. And we cannot use side, side, angle, and angle, angle, angle. So if the two triangles are congruent, so too are all of the corresponding parts congruent. We can abbreviate that as corresponding parts of congruent triangles are congruent. The parts are congruent. Or we can abbreviate that with the acronym CPCTC. We'll walk through two examples that use the CPCTC. First example, take a minute and sketch this in your notes. Our job is to prove or to determine whether segment CB is congruent to segment DA. So if we can establish that the two triangles are congruent, then we can use the CPCTC to verify that all the parts will be congruent to the corresponding parts. So take a look. We've got angle A and angle B. We know that I've got a side AM and BM. And lastly, I've got the two little angles. Because of vertical angles, I know 1 and 2 are congruent. And if you look at one triangle, the side is an included side, which means we'll use ASA to prove triangle congruence. So let's work that. With our corresponding parts that we know angle A and B are congruent because it's given information. We know segment AM and BM are congruent because they're given. Angles 1 and 2 form a vertical angle pair, and we know those are always congruent. So therefore, we can say that triangle AMD is congruent to triangle BMC because of the angle-side angle congruence shortcut. So now let's answer the question, is CB congruent to DA? Yes, it is, because corresponding parts of congruent triangles are congruent. One final example. Take a minute and sketch this thing. It's our job to answer whether segment AE is congruent to segment BD. So the question then is, how many different triangles do you see? There are a bunch of them. 3, 4, 5, 6, several triangles. The question is about segments AE and BD. So which triangles involve those segments? What we're going to want to do is separate out the two overlapping triangles. We see triangle ABD and triangle BAE. So those are the two triangles that we're going to use. And we want to decide first, are those two triangles congruent? Well, we know angle ADB is congruent to BEA. We know angle ABD is congruent to angle BAE. And so we're out of given information, but you'll notice because of the way that the two triangles overlapped, segment AB is shared by both sides. And so we can say that segment AB is congruent to BA because it is a shared side. So that means the two triangles are congruent, ABD and BEA, and they're congruent by angle, angle, side. So therefore, segment AE and segment BD are congruent by the CPCTC.